Hi, welcome to part 3 of our look at multiplication facts. Today our learning targets are I can find multiples of counting numbers and I can solve multiplication problems. We're going to be using our multiplication table again today, and we're going to start off by looking at multiples of counting numbers and also some cool fun little tricks that you can use the multiplication table to help you learn your multiplication facts. And if you've learned your multiplication facts already, this is just a way to help you stay proficient with it and maybe have some more fun with it too. So a look at our hundreds, or I'm sorry, not our hundreds, our multiplication table here. Our square products, or square numbers, are listed diagonally down the chart. So once again, these are just the factors that are the same factors multiplied together. And I want you to look at the nines multiplication facts, okay? So that would be this column right here. I want you to take a look at it. Now if you wanted to, you could have done this the other way too, and you could have looked this way. Both of these are the nines, okay? But go ahead and take a look for a second and see if you notice anything. Well, something I noticed that I'm just going to jot down really quick is as you go down the row, or to the next row, you increase the tens digit by 1, and the ones digit decreases by 1. So 9 becomes a 1 and an 8, and then the tens increases to a 2, and the 8 decreases to a 7, and then the 2 increases to a 3, and the 7 decreases to a 6. Alright, so that's something that I noticed in the nines column. You're just adding 9 on, okay? You could also add on 10 to each row and then just subtract 1. So I could do 9 plus 10 is 19 minus 1 is 18. 18 plus 10 is 28 minus 1 is 27. Okay? All of these numbers on the chart here, 9, 18, 27, 36, and 45, this is what we call multiples. And in this case, it's of the number 9. So 9 times 1 is equal to 9. 9 times 2 is 18. 9 times 3 is 27. Alright? So I'm multiplying our factor by any counting number. This is the 1 counting number, the 2 counting number, and these in this column right here, or in this row right here, these are all multiples of the number 9. And how we get them is by using our factors. Let's try another one. If I had you look at the 5s on a table, and this table's kind of small, I'm sorry. Let's see if we notice any patterns there. And you might say that all of the products end in a 0 or a 5. Every other row ends in a 0. Every other row ends in a 5. Notice also that 5, 10, 15, 20, all the way down are all multiples of 5. And here's a fun fact for you. Let's say you had the number 453,578,000 or 38,955. As long as the number ends in a 5, or it ends in the number 0, ends in 5, ends in 0, it is a multiple of the number 5. Pretty cool, huh? Now you can look on and on in the table for all sorts of little tricks and ways to help you figure out little tricks to memorizing the multiplication table or your multiplication facts. So take a look at it sometime and see if you have any little tricks that help you out. Something I wanted to talk about really quick are multiples, just a little bit further. And if I wanted to list multiples of 2, boy, I could have a lot of fun with this. I know that 2 times 1 is 2. I have 4, 6, 8, 10, 12, 14. I'm just counting by 2. These are all multiples of 2. 1 times 2 is 2. 2 times 2 is 4. 2 times 3 is 6. on and on and on. Now let's go ahead and take a look at our multiples of 3. I can just count by 3, or I know that 3 times 1 is 3. 3 times 2 is 6, so 6 is a multiple. 3 times 3 is 9, so 9 is a multiple. 3 times 4 is 12, so 12 is a multiple. And I could go on and on and on. But what's interesting is that some numbers are shared multiples. For example, 6 is a multiple of 2, and it's also a multiple of 3. Likewise, 12 is a multiple of 2, and 12 is a multiple of 3. Okay? So multiples are just not unique to one number. They can be shared by different numbers as well. So if we wanted to name 4 multiples of 7, we would find our 7's row, and we could say that 7 is a multiple, so is 14, if we just go down the row, so is 21, and so is 28. If I wanted to list all the factors of 18, I could take a look and see in my chart where all the number 18 showed up. I could do that. Or I could think about what two numbers I can multiply to get 18. I know that 1 times 18 will be 18. And if I had an 18 on here, we could find that. I also know that 2 and 9, if I were to look at my chart, I would see that 18 showed up here. So I know that 9 and 2 are factors. And then I can keep looking at my chart and finding the product. Oops. 18 elsewhere. But I also know that 3 and 6 is also a factor. So I can use my multiplication table and my products, and I can look for the number 18 and then move my fingers over to find the factors. If I wanted to name the product of 9 and 6, I would find 9 on the table. There it is. And then find 6 on the table on the other side and draw my fingers together until they met at an intersecting number, and in this case it's 54. So here's the 9, I would bring it over, the 6 comes down, they intersect at the number 54. And then same thing down below. If I wanted to list all of the factor pairs of 20, I could look at my multiplication table and find all of the places where I have 20. So here's a 20. So I know that 10 and 2 are factor pairs of 20. Let's see where else we have a 20. I know it ends in a 0, so I'm going to look in my 5's row and my 10's row. Here's a 20. So I know that 5 and 4 are factors. And then I remember from our discussion on prime and composite numbers that it's always going to be the number 1 times the product itself. So 1 and 20 are factors as well. All right, that's all for today. Keep practicing and we'll see you later.